Good morning students. Today I am discussing the next topic, that is hydrogen peroxide. Hydrogen peroxide is a pale blue color liquid and that is used in pollution control as well as it is used in the treatment of domestic effluents. Fine. Its boiling point is 423 Kelvin. Now there is various methods to prepare hydrogen peroxide in the laboratory. First method is by acidifying barium peroxide. If we are treating barium peroxide with an acid, that is sulfuric acid, then it forms hydrogen peroxide, that is H2O2. This is barium peroxide, contains 8 water of crystallization. When we are treating it with sulfuric acid, that is H2SO4, then it forms barium sulfate plus hydrogen peroxide plus 8 water molecules. This extra water is being removed by evaporation. Understood? Now second is auto-oxidation of 2-ethyl anthraquinol. 2-ethyl anthraquinol is this. This is 2-ethyl anthraquinol, and when we are doing auto-oxidation, then it forms hydrogen peroxide along with this additional product. It is 2-ethyl anthraquinone. Understood? Now, what are the physical properties of hydrogen peroxide? This hydrogen peroxide is miscible in water in all the proportion and it forms a hydrate. This is H2O2, H2O. This is hydrated hydrogen peroxide. Its melting point is 221 Kelvin. The density of hydrogen peroxide is more than water. It is 1.44 gram per centimeter cube. Its boiling point is 423 Kelvin. These are the physical properties of hydrogen peroxide. Good morning students. Today I am discussing the next topic, that is hydrogen peroxide. Hydrogen peroxide is a pale blue color liquid and that is used in pollution control as well as it is used in the treatment of domestic effluents. Fine. Its boiling point is 423 Kelvin. Now there is various methods to prepare hydrogen peroxide in the laboratory. First method is by acidifying barium peroxide. If we are treating barium peroxide with an acid, that is sulfuric acid, then it forms hydrogen peroxide, that is H2O2. This is barium peroxide, contains 8 water of crystallization. When we are treating it with sulfuric acid, that is H2SO4, then it forms barium sulfate plus hydrogen peroxide plus 8 water molecules. This extra water is being removed by evaporation. Understood? Now second is auto-oxidation of 2-ethyl anthraquinol. 2-ethyl anthraquinol is this. This is 2-ethyl anthraquinol, and when we are doing auto-oxidation, then it forms hydrogen peroxide along with this additional product. It is 2-ethyl anthraquinone. Understood? Now, what are the physical properties of hydrogen peroxide? This hydrogen peroxide is miscible in water in all the proportion and it forms a hydrate. This is H2O2, H2O. This is hydrated hydrogen peroxide. Its melting point is 221 Kelvin. The density of hydrogen peroxide is more than water. It is 1.44 gram per centimeter cube. Its boiling point is 423 Kelvin. These are the physical properties of hydrogen peroxide. Now students, see the chemical properties of hydrogen peroxide. It acts as both oxidizing agent as well as reducing agent in acidic medium as well as in basic medium. Let's see the first reaction. In this it behaves like oxidizing agent in acidic medium. It converts Fe plus 2 ion into Fe plus 3 ion, that means ferrous to ferric. That means increase in oxidation number, that means it acts as an oxidizing agent. Understood? Now reducing action in acidic medium. It reduces, just see. Here the oxidation state of Mn is plus 7, here it reduces to plus 2. That means decrease in oxidation number. In that case we say it acts as a reducing agent. Now next is oxidizing action in basic medium. In the basic medium, if any of the reaction takes place and we are using H2O2, so in that case it acts as an oxidizing agent. Here ferrous convert into ferric. Understood? Now next is reducing action. In basic medium it also acts as a reducing agent. Here it is iodine. Here the oxidation state of iodine is 0 and after the reaction it converts into -1. That means decrease in oxidation state. So here it acts as a reducing agent. Understood? Now just see the storage of H2O2. In the presence of light, H2O2 decomposes and the following reaction occurs. This is hydrogen peroxide. It is in liquid form. In the presence of light, it decomposes to give water and oxygen. In the presence of metal surface or in the presence of alkali, traces of alkali present in a glass container, this reaction is catalyzed. That means it becomes faster. That is why we have to keep it in mind whenever we are storing hydrogen peroxide. We have to store that hydrogen peroxide in a wax-lined glass bottle or in a plastic vessel or in any other container in dark always, because in the presence of light the following decomposition reaction occur. To stabilize that, we can add urea in H2O2. Understood? Now, what is the formula of urea? NH2CO NH2. Now, we have to keep it away from dust, because in the presence of dust, sometimes the explosive, we can say explosion takes place, explosive decomposition of this H2O2 takes place. Hence, we have to keep away from dust. Now, what are the different uses of hydrogen peroxide? Hydrogen peroxide is used as a disinfectant. That is why it is used in hair bleach. It is also available in the market in the form of perhydrol, which is used as an antiseptic. Understood? Next is, it is also used to make the substances, make some sort of chemicals that are very important to make high quality detergents. Understood? Next is, it is used in bleaching agents in textile industry, in paper industry, in leather industry, and it is used for bleaching. I have told you in the starting, it is also used for pollution control. It is used in pollution control of domestic effluents. In that way, there are several uses of hydrogen peroxide. Now, students, see the structure of hydrogen peroxide. This is the structure of hydrogen peroxide. It is in gas phase, and this structure is in solid phase. Just see what is the difference between both of them. In case of gas phase, it is having a dihedral angle of 111.5 degree. This is dihedral angle of 111.5 degree. This is HOO and H. Similarly, HOOH. This is H2O2. Similarly, it is H2O2. Here, the bond length of oxygen hydrogen is 95 picometer. Here, oxygen bond length is 147.5 picometer. The bond angle between this is 94.8 degree, and this is dihedral angle of 111.5 degree. Similarly, in case of solid phase, the bond length of oxygen hydrogen is 98.8 picometer. Oxygen bond length is 145.8 picometer, and this angle is 101.9 degree. Here also the dihedral angle is 90.2 degree. Understood the structure of H2O2 in solid phase as well as in gas phase. Understood? Now, students, see the next topic, that is heavy water. As we normally use water, we use H2O. Here we are using protium, the first isotope of hydrogen. Here it is heavy water. Here we are using the second isotope of hydrogen, that is deuterium. That is why instead of hydrogen protium we are using D2O, that is deuterium oxide. The heavy water formula is D2O. It is also called deuterium oxide. Fine. It is used as a moderator in nuclear reactor. Whenever we are using it, what is moderator? Moderator is used to slow down the speed of neutrons. That is called a moderator. So whenever we are using in a nuclear reactions, it slow down the speed of neutrons and the reaction occur properly. Now, how can we prepare D2O? We can prepare this heavy water by exhaustive electrolysis of water. Whenever we are doing electrolysis of water, we are getting hydrogen gas and oxygen gas. But when we are doing exhaustive electrolysis of water in some fertilizer industries, as a byproduct, we are getting this heavy water. Now, this heavy water is used to make various deuterium compounds. As we are using protium, similarly we are using here deuterium. It is calcium carbide CaCO2. When we are reacting with this heavy water, it forms C2D2. That means it is the compound of acetylene. It is C2H2, it is acetylene. So in that we are using heavy water, that is deuterium. Along with CaOH ka whole twice, if we are using hydrogen, that is protium, so we will write H, that is calcium hydroxide. Understood? Here we are using deuterium. Similarly, SO3, this is sulfur trioxide. When we are reacting with heavy water, it forms D2SO4. As we are saying H2SO4, it is hydrogen sulfate, it is deuterium sulfate. Understood? Similarly, it is aluminium carbide. When we are reacting with heavy water, it will form CD4. If we are taking protium, it will become CH4. Understood? Along with aluminium hydroxide, it is, we are taking, instead of hydrogen, we are using here deuterium. Understood? So these are used, this heavy water is used to make various type of compounds that are used in various chemical industry. Understood?